Okay, Calculus 2 students, this right here is for you guys. Here is the question. Suppose we put 400 fish in a lake initially, and let's say we know that the carrying capacity of the lake is meant to be 10,000 fish. And after 1 year, the fish has been tripled, right? And we are going to assume that the fish population satisfies the logistic equation that we talked about it. And we are going to find out how many years does it take for us to reach 5,000 fish. And let's go ahead and do this. First of all, this is the logistic differential equation, and we have shown that from here we can get to this. And you guys can check out my other video if you haven't seen already, but we'll use this formula for later on. Now, let's of course put down what we know and also what we want to know. Here is our situation. Of course, you have to remember all the letters. The P stands for the population. In this case, it will be for the fish, and the K is just the the constant of proportionality. M is the carrying capacity. So we can actually just based on this and write down dP dt is equal to K times P times 1 minus P over. And again, we assume that the carrying capacity of the lake is meant to be 10,000 fish. So just put that down right here. That will be our differential equation. And we also know that initially we have 400 fish, so P of 0 is equal to 400. And after 1 year, what happened? Well, the fish has been tripled, right? So that will be 1,200. Yeah, so of course, let me just write this down right here for you guys. It's because 3 times 400. That's the idea. And what do we want to know though? Let me just put that down right here for you guys. We want to find out how long does it take, right? So we want the time so that the population at that time will be 5,000 fish. And that's half of the carrying capacity. Let's see how long it will take. We are not going to do this like from scratch because again we have this formula. So all we have to know is that here's the equation. Now we can actually use the function, right? We know P of t. Again, from this differential equation, we can see that the m is 10,000. All we have to do is put the m right here. So we have the 10,000 here over 1 plus, well, let's also work out the c. C is what? M minus P0, meaning the initial population, and divided by P0. So let's go ahead and do that. C equals M is the 10,000, and then minus the initial, which is 400, and then divided by 400. And of course, you can work this out, and we get 24. So this right here will be the C value, and we have the 24, and E is still E. And we have negative K, we don't know yet, and then T. So that's pretty much it. So the idea is that it's really nice to solve for general solutions like this, right? General differential equation, and we have the general solution in terms of the m and all that. So we don't have to do the partial fraction from scratch again. All right, now, based on this, plug in, and hopefully you can solve for the K and also some other things. In fact, we used this already, right? We used this to solve for the C. So we actually have to use this, right? So here we go. P of 1. And again, if you use this right here, you just get 1, and then seriously, it's not going to help you how to use this right here to solve for the K. P of 1 equals, on the top, we have the 10,000 over 1 plus 24 times E, and then we have the negative K, and the T is equal to 1 right here. So just put down 1 right here to emphasize. And of course, P of 1 is the 1200, so I should have put that down right here. P of 1 is the 1200, and that's equal to this expression. Now, we are going to multiply this on both sides, and perhaps we can divide the 1200 on both sides. So it looks like this. We will have this 1 plus 24 e to the negative k on the other side. Divide the 1200 on both sides. So that will be equal to 10,000 divided by the 1200. I'm not going to simplify any of this. I'll just use the calculator later, okay? Anyway, minus 1 and then divided by 24. So you will see this is going to give us e to the negative k being this number, 10,000 over 1200, and then minus 1, put that in the parentheses, and then divide it by 24, right? And then we take natural log, so that this and that will be gone. Take the natural log, and we have the negative though, so be sure k is actually the negative. Let me just emphasize, we divide the negative on both sides, so we have the negative being actually on the right hand side now. So k will be negative natural log of all this, natural log of 1 over 24, 10,000 over 1200, and then minus 1. This is not in the denominator, so it's all that. And of course, that's also use a calculator to get the approximation for that. So I will of course do that real quick right here for you guys. And I get from the calculator, k is approximately 1.1856. And now we can of course put this back here, and then we can get the equation for p of t. So we have p of t being equal to 10,000 over 1 plus 24, and we have the e, and this is negative, don't forget about that, negative k, which is that 1.1856, and we have the t right here. So this right here is the equation. Now we have to set this to be 5,000. So I'll just make this equal to 5,000 right here. And now of course we can just multiply this on both sides and divide this on both sides. So we will have just 10,000 over 5,000, and we know this is 2, but let me just keep it as how it is. And that will be equal to this on the other side, which is 1 plus 24 e to the negative 1.1856t. Now I will minus 1 on both sides and then divide the 24 on both sides. So we get e to the negative 1.1856t being equal to this minus 1. I know this is just 1, but let me just write it down. Why not? Minus 1. And then divide it by the 24. So put this in parentheses and then the 24 like this. And then again, I will just take the natural log on both sides like this. And I will also divide this on both sides. So finally, t is equal to negative 1 over that, 1.1856 times this, natural log of 1 over 24. In fact, this is just 1. This is 2 minus 1, so it's all that. And if you work this out, you will get approximately 2.68. And we're talking about years, so just put down years right here. And that's it, right? And look at this. During the first year, the growth was only 800 fish. But after a year and like more than a half, well, you get a lot more, couple more thousand, because you will reach 5,000. It's crazy. And that's how the logistic differential equation works. You start off slow and it goes up really fast, and then it slows down again, right? So hopefully this helps. And as always, that's it.